Alright, so we have this thing. It's intensity RGB, IRGB, which is the VGA standard. We already talked about this before, so I'm not gonna jump too much into it. And I already have that enum right here. I'm gonna make this guy a little smaller. Actually, I'm gonna quit this because I like my things to be on the. I have no idea why hey goes. Oh, it has HE in there. Alright, thank you. Cool. Thank you. Get bigger. Alright. Cool, so we have the stuff, we have the stuff. Cool, now let's set up the VGA thing. First of all, in the spec, I have my color, which is RGB. We know how this works. I'm not jumping into it again and again and again. But again, just in case I'm making a clip, the way this works is we have intensity RGB. So for example, 0 and then 100 would be red. 0100 is basically to the power, it's 8. I'm guessing. No, wait, sorry. It's 012, right? So 2 to the power 2, which is 4. So red is 4, right? If you want something like, say, a light blue, let's say, so that would be 1 RGB. So 1001. 1001 is 1 plus 8, 9. Perfect. That's how it works. We can read up on this, but I know how it works. I have this guy, which is great. Then I have this color code, which is a U8, and we have wrapper transparent on it in order to have it use the same memory layout as the member type. Again, I went through this before. I want to get into this stuff, right? So let's follow the blog. Cool. So I have the colors. This is fine. We went through this stuff before. I haven't added these two right now because I'm gonna add the traits when I need them. That's how I prefer to write. Cool. So we have color code. This is just the same exact code as what we have there. So in VGA, the color code, the coordinate, if I may, has like 8 bits. Okay. So it's like the first 4 bits are for the byte itself, the character itself, right? One character is 1 byte, so I think it's 16 bits. Sorry, yeah. So it's the 8 bits are for character itself, and then we have 8 bits for the color, where there's foreground and background. So we have the divided by into nibbles, 4-bit nibbles. So that's how it is. So that's why we need to do this, where the color takes foreground, background, and then combines them. By combines, it just means puts them together, right? So we have to do left shift 4. So shift it by 4 and then add that. That's how it works, right? Cool. That's cool. So fine. So now we need a text buffer. So I think I've already done up to here. I have this character. Yeah, I didn't want to call it screen care, so I just called it character. Fine, whatever. Doesn't matter. For a character, what do we do? Yeah, ASCII character color code. This is straightforward. Okay, the buffer is where I was stuck and I didn't implement that. So let's do that now. All right. So since the field, oh, 1 second, I was making coffee. Alright, I have some caffeine and a glass. Not a glass, a mug. Let me pour some in. Texts are going crazy. but not now. I'm gonna check them out after this too. Alright. Cool. So as we talked about, our buffer's height is 25 rows and 80 columns. So we have that. So this is where I wanted to get the settings in, and I think I did that last time when I broke some stuff. So I'm going to do one thing. I'm going to have in VGA itself, in mod maybe, I'm just going to keep this in mod. Alright. Buffer height and width are there, and then buffer. What is this syntax? It's a 2D array where we have the screen character, the buffer width, buffer height. So we start at the beginning, right? So the first character we put at, instead of 0 0, we are putting it as buffer width and buffer height, which would be like the bottom right corner, I'm guessing. Cool. So this is fine. This makes sense. I don't have any working, but I'm not setting that up again. It's possible to set up a Alright, cool. So I have this guy. Sorry dude, my caps lock is on. Okay, so within spec, I think just spec was, don't worry about refactoring yet too. Fine, let's just go like this. Cool, so I have a struct buffer. So this also has to go with the same memory layouts. I think the wrapper for this is going to be transparent. Yeah, that makes sense. Right, so I have this guy, and it generally, yeah, it has characters. Okay, which is a 2D array. Okay, so I'm going to start with a character, comma, I need these guys. Okay, so buffer width, why is it not auto completing for me? Charts are too much with that still. I didn't do it. It's just a types, right? Yeah. Why? Why do I have to type that? This is the issue. Alright, so I have buffer defined. Of course everything is dead code right now, so it's not being used. Alright, and now for the buffer we can have the, okay, now we have the stuff. Now let's go for writer. Okay, it actually, this part is right. I'm gonna make this buffer.rs. Okay, I'm gonna rename this guy to color because that's all it has. It just has the color stuff. It also has a character though. Okay, dude. Sorry. You can be spec. What? The file is renamed to a viewer. No, I don't do that. I do this. This is called spec only. Characters and colors. It is spec. Cool. So I have this guy. I have the colors, and I have a buffer, which basically has this thing, and I need the use color super dot spec dot character. I'm just gonna replace. It is a public one. What's the issue? module is not public. Alright, cool. So I have the buffer now. This makes sense, right? It's basically the type character for each placement, and the height is the height and the width is the width, right? So that's how that goes. That's the buffer. Now we have that defined, so we can now do the writing, right? So okay, since field ordering in default structs is undefined in Rust, we have to do repc, which is on the screen cap. Okay, because we do want them to be ordered in memory in the same way as it's stored. Okay. Buffer, it makes sense, right? We want the same memory layout as a single field, so that's why we use repo transparent. All right. To actually write to screen, we now create a writer type, color code, column position, and buffer. Makes sense. So we are basically mutating this buffer as we go, and the column position is something that we initiate with probably a default, and then as we write, we increment the column position. That's my idea, right? I'm pretty sure that's what's happening. Yeah. Right. We do the memory writing like this. We keep updating the buffer. That's it, right? Okay. I'm curious how the buffer maps to the actual XB8000 memory area. We'll figure that out later, right? That's fine. Yeah, and if it's a new line, we call new line, and new line is something we have to implement later. This I am okay with. So let's do that. I'm thinking I'll put the writer in the buffer itself, or I'll put I'll make this writer. No, you don't rename the file. That's not how it works. You rename the module. Okay. What is wrong with Rust Analyzer? You can't do a simple refactor to it. Okay. Go to writer, and this guy can move back to spec. We already have it here as well. Alright. Cool. So it doesn't have anything right now. Let's start. So we need a struct called writer. Okay. We need column position. It's gonna be a U8. U size. What is the thing again? New code should use the associated constant directly in a primitive type. Okay. Oops, sorry. Yeah, color code, and we have the buffer, which is gonna be my guess is static mutable reference to buffer. That's my guess, because it's a mutable reference and we want the reference lifetime to be valid for the entire run of the program. That's my guess. That's what it is. Perfect. Alright, yeah, exactly, right? We have an explicit lifetime saying that this should be valid for the whole program to run. It's considered cheating in the general sense, but this is actually a valid use case for tick static. Okay, cool. So let's have a write thing now. Impl writer pubfn write self, needs self, and it mutates the buffer, so it needs to be a mutable reference. Makes sense. What else? Yeah, what byte are we writing? Oh, we don't need to get this thing. We'll see. Okay. Any returns? Result? Nothing. Okay. Unit. Okay. So first of all, if it's a why do you need iflet? If it's a direct match, dude. Match byte. If it's a new line character, then you do something. Right, I think let's just do that. Fn new line. I'm not even sure what that's gonna do. I just call self dot new line, because when we do a new line, generally what happens is we move to a new line, but here that would basically mean that we have to move to the next row in our 25 row this thing, right? So that's why we have to go new line. This guy has to take, again it's going to be mutable reference online, new line. All right, and other cases I'm going to thing. So what are we going to do? Let's look at it. Let's not look at, let's read what's happening. Okay, if it's new line, then we don't do anything, we just call this an implementator. Fine, other bytes are printed in the second case. All right, when printing a byte, the writer checks if the current line is full. That's the first check. Okay, in that case a new line call is used to wrap lines, which is what's happening here. So if the column position is greater than or equal to buffer width, we call new line. Makes sense? If it's full, we have to jump to the new line. That's the first thing we do. That makes sense. Alright, then it writes a new screen character to the buffer at the current position. So we basically, current position in the buffer is row column. Row would be buffer height -1. Why is it -1? Because we are starting from 0. Makes sense. Call is a column position. Okay. Okay. I'm now going to do this. Wait, why are we always starting from buffer? Are we changing the buffer height now? The row updates in the new line implementation is what I'm thinking. So don't we need that as well in the as part of the struct? So right now what they're doing is row is always buffer height -1. It's always the first one. But what if the column has shifted? Oh, we are got it. So we are just overriding the same line right now. Okay. Okay, again, let me make sure I'm live. Okay, again, let me make sure I'm live. Okay. What about the music? Yeah, it's fine. Alright, so I need another sip of coffee. This is very straightforward, the rest of it. The only thing not clear is, okay, why is a color code also like a self-taught thing? Because the new writer is in a particular color. Why can't you have mixed colors? Okay, I'm already thinking of the possibilities, but this is reasonable, I think. Yeah, that makes sense. I create a writer for yellow and we write in yellow. That's fine. Only thing that's like biting me right now is this. Why are we doing this? Why not take the row as input? We want to write at the bottom right now. That's why we are doing this. Fine. Let's move with it. Okay, let's go. So, why are we... okay. B. What's the problem? This is B. Single quotes. Yeah. Alright. So in this case, what I have to do now is, the first thing, if our self.column position is greater than or equal to buffer width, I need the buffer width. Are you kidding me? Why can't that? I don't want this to be a constant. This is a pre-allocation thing, dude. Like, I could have done a vec here and taken the height and width as input and allocated accordingly. But then the type here would be confusing. Fine. I just made a pub constant, fine. So I'm just gonna go EGA spec buffer width. So if that is greater, then I just do self.newline. Alright. The next thing I do is write the byte. That's it. Let's write the byte first. No, I need the row and column, right? So the row, we are taking the last row, which is, oh what? I don't like doing this. Okay. Okay, this is spec dot buffer height -1, which is basically last row. Okay, and call is current position, and all I have to do is self dot buffer of row comma column call equal to the byte, no, not the byte, screen char spec character is public. All right, character new has, okay, bytes, I'm guessing, yeah, okay. So the B and code, which is the color code. Why would you forget the semicolon? Are you kidding me? I'm coming from gold. Okay. What color are we choosing here? As part of the writer, so self.color code. Alright, so I do that. Of course I have to do a let. I'm surprised I didn't do a colon equal to here. Okay, so row is usize and buffer expects, I think, u8. So I have to do this as u8. No? Okay. What is it? Cannot index into. Isn't that what you're doing here? You are doing here. Dot chars apparently. Oh yeah, the buffer has chars, right? Show me that. Oh yeah, this thing is called chars, right? I like it. Characters. Layout. Chars it is. It's okay. It's okay. I was thinking a few things, but I don't want to go with those things right now. Yeah, buffer is a reference. You can't if you do chars, and the reason you can't do that right now is because this has to be pub. Function coloring is just painful, dude. Okay, color code. Let me figure out what's happening. We'll go to the writer. Okay, color code is a mutable reference, buddy. Mutex what? Color code. No, that's a problem. Color code can't be a reference. Okay, so one of those things. Did they clone? They did not clone. Why didn't they have to clone? What is spec? I think I need coffee. Go back. I shouldn't need a clone now. Yeah, perfect. Because it's just a simple struct that is basically just a few U8 stuff. So it's just, yeah, it's just U8. So there's no harm, and it can just have a copy. All right. So I have this stuff which matches this, and we're good. Of course, once we are done writing, we have to change the column position to 1 by 1, right? So that's clear to me. Alright, that's fine. We have the writer now. Okay, To print the whole strings. To print whole strings, to convert them into bytes and print them one by one. Okay. We're appending a new line. I like that. I mean, okay. Print line then. Fine. What is this? Only supports ASCII and the additional bytes over here. Rust strings are UTF-8 by default, so they might contain bytes that are not supported. That's what this range is. Okay, what is this character? FE. What is that? I think it's a fixed color, a fixed byte. It's a square bracket or something probably. Okay, that makes sense. This is not write string to me. It's print line. Right? Alright. So pub fn print line. What's up with you? Actually, yeah. Write line. Okay, that makes a little sense to me. Okay, we of course need the mutable self-reference here, and we need bytes. No. We take a string. All right, and then for b in s. Okay, I think if you do bytes on it, you get bytes directly. That's what they did. Alright. So if it's in that, I'm just going to copy that bit. So 20 to 7E. We have a new line being added in the beginning itself. Why is that? Okay, this part I'm not clear on. Why are we piping the new line in the met check? Oh, because whatever we do here is what we no, we're just passing on byte. Why are we doing this? Why are we doing the pipe new line on match arm when we pass byte in? Oh, it's an OR. It's not, it's just an OR. Okay, new line is not in this range. No, I'm not gonna do that stupid unreadable crap. Just give me this range. Okay, if it's this range, one sec. Match B. Okay, if this is the case, I'm gonna do self.write by write byte. Okay, if it is new line, I'm going to self.write b. Else I'm going to do self.write xfe. Zero xfe. That's so much more simpler. Alright, I have this guy now. That's good. Cool. So now that this part is clear. Oh, it's a tilde character. This is a tilde character, right? Oh no, this is the tilde. This is the thing we are printing. The unprintable stuff. Okay, new line or anything between space and tilde. That is what this range is. I want that. It's ASCII basically. ASCII and space, anything within space and tilde. Okay. Alright. Which is still ASCII, right? That is what ASCII is, not AND. It's just ASCII, dude. Alright. Cool. Don't go defining ASCII in a comment. Alright. So this is fine. Try it out. So you create a writer and you write bytes and you write strings. Okay, so you have write bytes and write strings. Yeah, fine. Yeah, I think this is more of write string. We're not doing the new line thing that I thought. So it's just yeah, this is right. This is right. This is right. Sorry. I always do this way. Sorry. Alright, thank you. Okay, but how is it gonna work without doing the X1000 thing, dude? Where did I do that? What is this? What is this thing? In the okay, we're passing it right here. So if we do this thing as mute buffer, when we cast it as a buffer directly, yeah, it's weird, dude. We take an integer as a mutable raw pointer. This has to be unsafe because we are doing mutable reference shit. That's okay to me. But yeah, this is a strange one. It first creates a new writer. That's okay. In the writer, the buffer part is clear. I do have a buffer new, right? Don't I have a buffer new? I should have that. I need a new. One issue though. Column position 0 is fine. What was the row? We are not touching the row at all right now. I'm only looking at the last row right now. That's fine to me. Okay. So this guy, I don't want to copy paste it. I don't understand. What are you trying to do? First we cast the integer this as a mutable raw pointer. Okay. But we did it as a buffer. Raw pointer to a buffer. Fine. So we cast it as that. That's the first part. Okay. Then we convert the mutable reference by dereferencing it through star. That makes sense. And again, borrow it again. Why are we doing this? It needs unsafe. Okay. Compiler can't guarantee that. Of course, compiler can't guarantee craziness like this. Why are we doing this though? Why isn't this enough? What does this do? Why not just use oh, what's the type of buffer? I got it. Buffer का type क्या है भाई? Where is writer defined? It's a static ref. Okay, got it. Alright, so the new thing here, I'm gonna have a pubfn new still, which is gonna just return self, right? That's it. Sorry, what happened? Yeah, it's gonna be returning self. This is not necessary because we're doing the casting right there. The casting is enough. Alright. Can I have a writer new at least? Pubfn new. Okay, so this is gonna be a writer, column position 0. I need the color code. Take column position as well. call code, call code. You can do that way. Color code, no sorry, column position view size and color code. Okay, so the first thing I'm going to do is just get those. Okay, and then the buffer, so I'm going to go buffer is gonna be, so we need a mutable reference first, right? So this whole thing is unsafe. Sorry. Okay, so I need a mutable reference to something, right? So first of all, I have the XB OX8000, XB8000. What is the thing? OXB8000. So first of all, I have OXB8000. Leave it at that. Okay. It found I32. It expected the mutable reference to buffer, right? So I first of all cast this as a mutable reference to buffer. That's the first thing I do. Okay. Show me the guy, dude. Column position could not find in the scope apparently. It's right here. What's your problem? A field by that name exists in cells. I don't know why column position was crying, but okay, whatever. Fine. Okay. Yeah, show me the error. Not the syntax error, dude. Expected unit found I32 apparently. Line 7, that's the one. This is what I want. So I found a raw pointer and a mutable reference to it, right? So the first thing I'm going to do is this whole thing will be immediately dereferenced. So it's going to be a mutable reference to a dereferenced raw pointer. Where did the dash come from? It's as. Why does it jump around like that? Quit. Alright, perfect. So I have this stuff now. Now let's go to main rs. I'm gonna remove this guy. Alright, I'm gonna say writer equal to writer. You're not public. You are public. Writer is not public. Writer new. Color column is 0 and color code let's create right here. So color code new has the thing. What does this take? Front and back basically, right? It's gonna be a color dot color, I don't know, red, and color light blue, cyan, light red, and light green. Okay, and this is gonna be green. Syntax error. Alright, so I have the writer, and then I can just do writer dot print, dude. This guy is print. Printf. Print, we're not formatting, this is print. Alright, and it's writer dot print. Hey, welcome. Okay, this guy has to be mutable, of course. I don't need that thing anymore. Whoa, are you kidding me? I get rid of this. Let's see, dude. It compiles. Let's create a boot image. I love Suno, dude. The music is just amazing. Alright. Let's do this. It's hey welcome on top only. Why is it on top? Nope. RM, RF, target x86 thingy. Create it again. Wait, was the color right? I didn't see. What happened? No such file directory. Why is that changed? Oh, because it's released this time. Oh, this was a different binary. Okay. Did I do release? Oh, that's why the path is different. I have a hello. Oh, that's what the background color means. Okay. Let's change the foreground color to red or maybe blue. I don't see it as blue. Hey, it's not Python, dude. You have to compile the whole fucking ISO. Not ISO, but you know what I mean. Alright, our hello should now be. Okay, the foreground color is okay, one second. Sorry. The foreground color is wait. What is new? Foreground. Wait, what am I getting right now? I'm getting the foreground. Yeah, foreground is green and background is blue, right? That's fine. Isn't that what I'm passing? Foreground is yeah. No. Okay. Foreground, background. Blue and green. It's the opposite. Why is it the opposite? Let's see. So I think this is supposed to be. Let's see if that. I mean, that will probably solve the thing. Yeah. What was it in the example? The previous one? Not previous one. VGA text only. The initial colors, color code. Yeah, it's background and foreground. What did I put? Yeah, okay, I done it other way around. Dude, we have colors here. I don't know. How do I make this guy bigger? I don't know, dude. I don't know. Maybe just a command plus work? No. Oh, it captured my shift option, control option. Alright. It's a VM, dude. I can literally make a bootable USB with this and boot. Alright, and that's it with this VGA.